worked on 2 days of the skills around this stuff, the 3 different types, right? We've got the polynomial type, the rational type, and the square root type. And the very first day, if you remember, let me go back to it actually. Hopefully this is the right day. Uh-oh, I don't have it here. Oh no. I don't know if I'm going to be able to find it, but let's see. Here we go. The very first one of these that we did it with just, oh, you can't see that, with just A, right? And we looked at finding an expression, but we haven't really done that since. Usually you're given the point, and you have to use it and calculate the slope of the tangent at that point. But this was also something that we did, and there was a reason why we did it. Okay? Now, how is this question different? Yeah, so previously you were given the point, you're finding the slope. This is giving you the slope, you're finding the point. And that you should be pretty used to that by now. That's kind of what we do in mathematics. We learn to go one direction, then we learn to go the other direction, right? And some of these questions can be a little bit of problem solving. Some people do get stuck on them a little bit. They don't understand what's being asked. For the most part, they're all going to be pretty similar and straightforward. But there are different kinds of these questions that can be asked in different ways. And so that comes down to problem solving. And hopefully all the way back to grade 9, you did a little bit of this kind of problem solving. And hopefully your teacher you remember some of what your teacher talked to you about problem solving skills. So we're going to just talk about a couple of those. One thing that you might do is you might visualize what exactly is happening here. Okay, so we're going to do that. We're going to do a little sketch, but I'm also going to do this. This is something I like to do in general with slopes of tangents. So there's the actual function that we are looking at, 2x squared plus 5. So it's shifted up 5. And this isn't the point necessarily. Do is I can drag it around, and I can see how the slope changes as I drag it around the function. And this helps me sort of think about how different points along the function, the tangent has different slopes. What's true of all these slopes right now that we're looking at? They're negative. And what's true of all these slopes? They're positive. So if we're looking for a slope of positive 8, it's going to be around here somewhere. And positive 8 is fairly steep, so it's going to be over here somewhere, I would imagine. I don't know exactly where, but something like that. So that might be helpful for you to kind of sketch. Just do a simple sketch of what this graph looks like. Sometimes you'll be able to sketch it, sometimes you won't, so that's fine. And sort of think about where that might go, right? Where that tangent might be. And in this case, because we can sketch this somewhat accurately, it might even kind of help you check your answer. When we get an answer, if I got like -10, I'd be like, I don't think that makes any sense. I must have made a mechanical error somewhere. The other big problem-solving technique, I think, when you come across any question that's a little bit different, that's a little bit new, is kind of write down what you know, write down the formulas that are relevant to what you're solving. We only really have one relevant formula that we've been working with in this unit, and it's the slope formula, but we write it as a difference quotient with a limit in it, right? We write it in the limit form. So let's go ahead and do that. And it looks like this. And as we already said, usually we're given a point. We're given the function f at x. We're still given the function here. Usually we're given a point, and that's a, and we solve for slope. So how do you think we're going to solve this question? What do you think we're going to do? Okay, very good. So we sub in slope. We sub in what we have, and we solve for the rest.
And isn't the top supposed to be like 8 times bottom?
Say that again?
Like the top, like
F at x minus f at a?
Yeah, can you just say that f at a is 8a?
No.
No.
What you're saying is it's going to be 8 times?
Yeah.
I mean, yes, that's true, but I don't think that's going to help us. I see what you're saying. Because like if it's 8 over 1 on one side, it's got to be 8 over 1 on the other side or something like that. 8 times. Yeah, but I don't think that's going to help us. And we've got this limit in here and stuff anyway. So like there's... Oh, f at x. Since we're subbing in, we're going to sub everything in. So f at x is 2x plus 5, or 2x squared plus 5. So I'm going to go 2x squared plus 5 minus f at a, which is 2a squared plus 5, right? So this is where people get a little bit stuck and they're not sure what to do. And then just like that first date, we solve this to the end to get an expression for a, but this time it's actually equal to something already, and then we just solve for a. And that part will probably be pretty easy. Let's give it a try. So the 5s add to 0. And I get 2x squared minus 2a squared. So if I factor out the 2, I get a difference of squares. Now we can sub in. Yeah. Because remember, a is usually a value like 2 or something. We sub 2 in. As x approaches 2, as x approaches a, that's the thing that we're subbing in. So typically as a standard, we would sub a in for x, not x in for a there. What did we find, after all? Sometimes with problem solving, you get to the end, you're like scratching your head, okay, so a equals 2. What the heck does that mean? Abdul? Close. It's the x part of the point. It's the x value of the point. Is that what we were asked to find? What was our question? Our question was, what is the point? Isn't that everybody's question? What is the point? So we're not just supposed to find the x value. We're supposed to find the full point. So we just do f at 2, which is 8 squared plus 5, which is 13. Therefore, slope of the tangent equals 8 at the point 2, 13. Not too bad? Yes?
Where did the 4a come from?
A plus a is 2a times 2 is 4a.
Oh, yes, sir.
Yeah. Yes?
I know for like these ones, it would make sense if we put therefore statement, but like for the ones we did yesterday, do we do that too?
I don't think so. Usually you're finding the slope of the, kind of depends on how you set it up, I guess. But if you say, like for those ones, when you're working on them, if you say slope of the tangent equals, and then you equals, you've got like slope of the tangent equals that you're supposed to find. So for those ones, I'm fine that you don't need a therefore statement. Therefore statements are really for making sure you've answered the question. And like in word problems, when you get x equals 10, that's not answering a question, because the question was how far did Billy run, right? X equals 10, that's not answering the question. So you interpret the answer. Same thing for this. If I get equals 13, that's not really an answer to the question. So we just want to put it together as a point is really all we're going to do. Yeah. Everybody good? All right, let's try the next one. We're just going to do one of each type of the functions that we are capable of working with. That was polynomial. Now we're looking at a rational. That's one of the three things that's a little bit different about this question as you're writing it down. What else do you notice is just slightly different, just little things, but... Okay, so it doesn't give us a slope. It says parallel to. What's that talking about? This is from grade 9 again. Same slope. Parallel lines have the same slope. So parallel to some other line means it has the same slope. So that's going to be part of it. The slope of this line is 5 over 9. Slope that's parallel would be 5 over 9. So the slope of the tangent is going to be 5 over 9. You don't actually have to write this down 3 times, but that's the little deduction that we make there, right? What else is different? Different function, like I said. What does this mean? More than one. When it's in brackets, it means maybe more than one. Maybe not. So that's going to be part of it. Most of the questions will be worded like that. You have to know if there's one or two or more. Or in fact, it's possible you could have answers where there are none. This is a simple rational function. It's not, again, not the kind that's got all the different things happening to it. This one, there's two different ways a graph like this might look. We're going to look at this actual graph momentarily, but it could look like this. And it'd be shifted, right? It doesn't necessarily have asymptotes on the axes. Or it could look like this, and in fact, this one does look like the red curve, not the green curve. Does anybody notice anything about this when you look at this and you start to visualize slopes of tangents? What do you notice? No?
I would say that's enough outcomes in that because it wasn't clear.
Okay, yeah, interesting. What else? Say again? Yeah, that's sort of true. I understand what you're saying, not on the inside of the curve. Yeah. Okay, let's take a look at the actual visual. Let's look at this one. Whoop. So this is the actual function. What do you notice about anybody? Anything? Yeah, it never intersects the other one or whatever. Yeah, that's interesting. Yeah, they approach the asymptotes in a way, actually, don't they? Mm-hmm. There's lots of things that you could observe about it. The one that's relevant to us, I notice like all these slopes are positive. Do you notice that? I can't make a negative slope on this function. All these slopes are positive. And vice versa, if I was looking at the green one, all the slopes of the tangents would be negative. So this is a positive slope that we're looking for. So again, it's got to be the red one. I also kind of noticed, can make like I'm just estimating here, but here's a slope here. And if I kind of go there, that looks like about the same. So it looks to me like there's probably going to be two. Because as I go around this curve, you're kind of getting every slope that's, like every number that's possible as a slope, right? So I'm going to get one up here on this part of the curve and one down here on that part of the curve. That's what it looks like to me. Looks like to me, it makes sense that this kind of a function would have two solutions.
Did you just flip the point if you find one?
No. But there is going to be a symmetry to it, but it's not quite that simple. Yeah. Okay, so that's kind of interesting. And there is a property of graphs that we've talked about many times in this course. that is related to this exact idea that these slopes are all positive, that every slope of a tangent for this curve is positive. There's another property, and I just want you to think about this and see if you can come up with it, and you can tell me about it later. One of the properties that we've talked about, that we've described throughout the course, is related. It means the same thing as all the slopes of all the tangents are positive. Okay, let's do this. So I've got slope of the tangent Now I'm going to give you a little tip. This math here, doing this common denominator, is a little bit heavy. So to avoid writing all the rest of the things that are part of this question every single time we do it, sometimes we do a little cheating where we kind of go, I'm going to do the math for just the numerator, this part of the numerator. I'm going to do this over to the side and then continue the rest of this question when I get it simplified. And what I'm going to do is I'm going to get a common denominator of 2 minus x times 2 minus a. So I'm going to do 3x minus 1 times 2 minus a. Minus 3a minus 1 times 2 minus x. So distributing the first two brackets, whoops.